So welcome back to the channel, guys. Hope you're doing extremely well, and this is your very own mass coder this side. So let me welcome you to another lecture of binary tree, right? In this video, we're going to discuss the post-order traversal, right? Okay, so firstly, we discussed about pre-order, which was root followed by left followed by right? Okay, then we discussed in-order traversal, which was left followed by root followed by right. Now the post-order says left followed by right followed by root, right? So firstly root was at first position, then at second, then at third position. So it is left, right and root, right? So if I try to write down the post or traversal of the given tree, what would it look like? So for firstly I will go towards left. So 2 left, 4 left, left is not present, then 4 right, that is 7. So write 7 first, then go to 4, okay, then go to 2, okay, then 3 is left, then 5 left, 8, then write 8, then 5 right 9, then 5, then 3 is right, that is 6 will go towards left, 10's left is not there, 10's right, that is 11, after that 10, after that 6, after that 3, and after that 1, that is 7 4 2 8 9 5 11 10 6 3 1, right? But it is a lot more confusing, right? So what do? We apply a hack as discussed in all videos. For the pre-order traversal, we apply the dash here. For an in-order traversal, we apply the dash here. But now for the post-order traversal, I will be applying the dashes on the right side of the nodes. That is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Okay, so now again traversal. That is go something like this. Intersection 7. Intersection 4. Intersection 2. Again traverse, intersection 8 traverse, and intersection 9 traverse, intersection 5 again traverse, intersection 11, then 10, then 6, that is 10 6, after that followed by 3 and then 1, 3 and 1. So I hope that this approach is also clear to you, the normal approach, the hack, right? Okay, by this method you will never get the boss or traversal wrong. So if the college exams or any MCQ type exams ask you what is the force or traversal of the given tree, please use this approach because this will guarantee you the full marks. All right, now again how to code it, okay, for the pre-order we use the recursion, right? So first discuss the recursion first. For the pre-order, the codes look something like this. First I will go explore the root, then I will go towards the left function, then I will go towards the right function, right? Okay, for the in order, the function looks something like this. Go towards left, explore the root, then right. Post order, just follow the strategy, right? Just follow the strategy along with that is go towards left, then right, and now if my root is not null, in that case go towards root. That is the code for recursion. Will look something like this. Suppose I make a helper function and I get my root here. What will I do? I will say if my root is not null, if my root is not equals to null, then firstly go towards left. That is helper function of root left. Helper function of root left. After that go towards right. That is helper function of root right. Helper function of root right. Then explore the value of root, that is print root value. Instead of printing, you can also add it into the answer array, right? Okay, now this is my recursion code. As always, it is very easy. Now but the iterative code is somewhat that is actually more fun to look at, right? Because that actually explains you how to actually form the code, actually form the intuition of thinking, right? So let me make down the tree again here. So this is my tree here. This is a post-order traversal we explored earlier in the video. Now, we all know that we will be using the stack. Why? Because recursion works on the basis of a stack data structure only. So we will be using the stack again. In the pre-order, it was actually very easy to pop out the root, print the value, then push it right, push it left, right? In order, it was not actually easy because we were using a boolean. We were using a boolean to keep account of the left, But the problem now is in the post order for a root, I have to explore its left first, then its right. That is, I will have to explore left, then right, and then come towards the root. So what will happen? In the case of in order, we will only keeping one bool, but in the case of post order, we will be keeping two bools, one for left and one for right, one for left and one for right, right? So what I will be doing is I will be storing something like this. For the given tree, I will make a stack. I will make a stack, right? Suppose this is my stack. Okay, so I will push the root with 1 0 0. What does 0 indicate? That the left tree has not been explored yet. I will pop it out. I have got 1 0 0 in my hand. Now because I'm exploring it, so 1 1 0, that is left has been explored, and because left has been explored, that is push 2 into it. So 2 0 0. Pop out 2 0 0, right? Push in 2 1 0 and the left of 2, that is 4 0 0. Then 4 0 0 will be popped out and it will convert to 4 1 0 with left. Left is not there. Okay, now when I pop out 4 1 0, I will see the left is explored but the right is not explored. So that means I will have to explore right first. So it will convert to 4 1 1 and I will explore the right, that is 7 0 0. Then first it will convert to 1 here, then it will convert to 1 here, and then after popping it out, when I pop out 7 1 1, that is both left and right has been explored, and then I have popped it out, that means I am free to print 7. I print 7. 7 is not more in the stack. I go to 4 1 1, I see 1 1, that means I can print 4 now. I go to 2 1 0, I see explore its right, right is not there. Okay, pop it out, print 2. Okay, I go to 1 1 0, I see, make it 1 and go to 3, that is 3 0 0. Again 3 0 0 will convert to 3 1 0 with 5 being pushed, so 5 0 0. 5 0 0 will convert to 5 1 0 with 8 being pushed, so 8 0 0. 8 0 0 will convert to 8 1 1 and 8 written here. Then 5 1 0 will convert to 5 1 1 with 9 being pushed, so 9 0 0, which will go to 9 1 1 eventually, and then I will print 9. Then 5 will be printed, and after that 5 I will go to 3 1 0 and I will push the 6. So 3 1 0 will convert to 3 1 1 with 6 being pushed, that is 6 0 0. After that 6 1 0 with 10 0 0. Then 10 0 will get to convert to 10 0 1, and then after making it 1, it will convert to 11 0 0, which will turn into 11 11 1 1, and then I will write it. Then after that 10 will be written. After that 6 will convert to 6 1 1 because right is not there, so I will write down 6, and then after that I will go towards 3, I will pop it out, 3 will be written, and after that 1 is left in the stack, so I will print 1, right? I will print 1, and the exactly matching post order traversal, that is 7 4 2 8 9 5 11 10 6 3 1, right? So what was my code looking like? I created a stack. Now my stack contains 3 elements, stack of pair of node. In the first element is node, then a pair of int comma int, right? Let name it as stack. Now if my root is not null, in that case stack dot push, what do I push? I push root with 0 0, right? Now while my stack is not empty, what do I do? I say my node equals to st dot top dot front, st dot top dot first, that is this node. Then my left, whether my left has been explored or not, will be equals to st dot top dot second of first, that is among this second, get me this value. Then right will be equals to st dot top dot second, that is this value, and I can easily pop that out element, pop the element out, right? Okay, moving on. Now if left equals to 0, that means left has not been explored. In that case st dot push, what do I push now? It is pretty evident that if left is not explored, right is not explored. In that case st dot push, what do I push? I push the same node first with left as 1 and right as 0, right? Okay, and after that if my nodes left is present, if my nodes left is not null, in that case push that also. So st dot push, now that will go with 0 0 because its left and right have definitely not been explored right now, right? It is not left here, node left, right? Okay, this is my first case. Otherwise, else if my right is equals to 0, else if my right is equals to 0, what happens in that case? That means left has been explored, but right has still not been explored. So st dot push, what do I push? I push the node with 1 comma 1, that is both the trees are explored now. And if my node's right is not null, if my node right is not null, in that case push that element. So st dot push, what do I push? The node's right with 1 comma 1, that is this tree has this node has explored its left and its right. So whenever you encounter it next, oh it is, sorry, it is 0 comma 0, this is 1 comma 1. Okay, now else, that is both of them are 1, that is left is not 0 and right is not 0. In that case both of them has been explored. In that case what can you do? You can just print the value of the node. So print node value, right? And that's it. You don't have to do anything. After the while loop completes, you can simply return because you have got your answer. You have printed the in-order traversal. Pretty good. Okay. Now, this is not the approach that all of the other YouTubers or the articles will tell you, because they deal with 1 stack and 2 stack without dealing with these values, the boolean values, right? They have created some other algorithms, but I don't find them intuitive. I think that they are actually of learning. You don't have to learn anything in the coding. You have to make the logics by yourself. See, that is why I'm telling you this approach. But if you want to learn that approach, the YouTube is filled with that content. So please just search in order iterative traversal, and you will get millions of videos there. But this approach was designed by me because I was finding very hard to learn them. Okay, so please don't spread hate in the comment section if you want only these two approach. Okay, you can find them anywhere else also, but if you like this approach, please comment down and give me the support and like the video. Okay, now it is time for us to see the recursion code as well as the iterative code. Okay, so let me move to the coding section now. Alright, so here is the coding section in front of you. Let us start writing the code, but before it, please subscribe to my channel if you're liking this playlist and you are able to learn anything from it, because it really motivates me, right? And so very sorry to say only 10% of you have subscribed, so that really demotivates me. Okay, now first I will create the vector of int answer, right? And then I will call the helper function for Postorder. Let us name it as, let us send the root there with answer. And after that I will be returning the answer, right? Okay, let me define the helper function. So void helper, which is taking my node tree node star root with my vector of int answer, which is sent by reference, because I want the answer to be storing the values instantaneously, right? Okay, now if my root is not null, in that case what will happen? First I will call for the left. So helper of root with answer, root left with answer. Then call the helper for the right. So root right with answer. And then it is not helper, it is helper. Okay, and then you can just push the value. So answer dot push root's value, right? Push back, right? Push back. Okay, and then you can just simply return. This will give you the answer. And let us try to compile and run it. It should run fine, I guess. Should not give any error. And it is running fine. Let us try to submit it as well for the hidden test cases. So this was my recursion approach, and let us try to write the iterative approach now. So I will comment it down, right? Okay, now what will happen? First I will create a stack of pair of, first I will create a tree node star, first element is my tree node star, right? With it I will be storing the pair of int comma int. You can store the boolean values also, right? So okay, and let us name it as 3. Now if my root is not null, in that case only I will push it into the queue, right? So st dot push, what do I push? I push my root with 0 comma 0, because the trees have not been explored, the left and right subtrees have not been explored. And now while my stack is not empty, my tree node star node is equals to st dot top dot first, right? And int left equals to st dot top dot second dot first, as discussed, and int right equals to st dot top dot second, right? Now if my left is equals to 0, that means left has not been explored yet. And if left has not been explored, it is of no option that right has been explored, right? So first what do we do? St dot push What do I push? I push the node which I popped it out with 1 comma 0. That is, in the frequent step, I will be doing the left subtree exploration. Now, if my node left is present, then st dot push node left along with 0 comma 0, right? Because the node left has to be explored fully, right? Else if the second option is right is equals to 0. In that case, st dot push, what do I push? I push the node again with 1 comma 1. That is, both the trees have been explored. And if my node's right is present, that it is not equal to null, that means st dot push. What do I push? I push the node's right with 0 comma 0, right? And now in the else case, what I will be doing, that is, left is explored, right is explored, you just have to push it into the answer. So answer dot push back, answer dot push back nodes value, right? And now you can just simply turn your answer. Let us try to compile and run it. Hope it will work fine. Should not give any error, I guess. It is running. Okay, there has been some mistake. Okay, I have not have popped it out. So st dot pop. Okay, let us try to compile and run it now. Should run fine now. Okay, it is getting accepted. Let us try it for submit as well. Should give not give any error, I guess. It is running fine. So, and it beats the 100% of users. So thank you for watching, and we'll meet again tomorrow with a new video on the binary tree. So please stay tuned, keep coding, and okay, thank you. Have a nice day.